Hello friends, welcome back to your own channel. I hope you are excited for this third part of Learning Python series. And this series is specifically designed to learn Python when you are a beginner or you are not aware anything about programming, you don't know programming. So this particular series is designed for you people. So stay tuned. Before we jump and learn more about Numpy and Pandas in today's series, I would like to give you a highlight about our video and how is our end look like. So there you go. Okay, so let's begin. In our first section of this video, we are going to look at one of the most important library that Python have, that is Numpy. So Numpy is a short form of numerical Python. This package particularly is meant to do the mathematics and which is more advanced than just calculating plus, minus, and so on. And this includes special functions like when you wanted to calculate cosine, exponential, standard deviation, mean, median, maximum, minimum, those kind of things. On top of this, we can also generate samples from many type of random variables, and that's very important, especially when you don't have data and when you want to practice something on Python. So this will be very important. Numpy also has a powerful data type to define vectors, matrices, and tensors. And hence Numpy is kind of a base library for every machine learning model. You would definitely use Numpy for sure. And with this data types, Numpy also allowed to do some linear algebraic function. It will also allow you to do matrix multiplication and matrix vector solutions. First thing first, we need to import Numpy library. And how do we import Numpy library? You can use this line of code which I have written here. You will write import numpy, right? And that will do your work. But then we also give alias. We're saying that import numpy as np. Now, np is nothing but an alias because you're going to call different methods from numpy. And that's why you need to tell Python that I'm using this library numpy, and from this library, give me this method. And that's why you need alias. Otherwise, every time you need to write numpy. So that becomes like cumbersome. To ease it out, people use aliases. And np as an alias is being widely used. So you can do import numpy as np. And when you run the code, it will take some time to import numpy in your notebook. In case if you have numpy not installed in your notebook, what you can do is you can write this code in your Jupyter notebook, pip install numpy. Before pip, you need to put this little exclamation mark here. And once you execute this code, this will install the latest numpy version in your system if it's not already there. But if you have followed my part 1 of Python learning video, and if you have installed the way I have installed the Python, I think you already have a numpy library in your system. So you need not to worry. In case if you don't have it, you can use this line of code to install that before you import Numpy library, right? Let's move to the couple of quick mathematical operations that Numpy offer. So how we can call different methods in Numpy is we use this np because this is the alias for Numpy we have given. So we say Numpy, and whenever we put dot, that means we are calling a method from that library. So we are saying that np.cost. Cost is nothing but a cosine. So I'm saying that I want a cosine value of 0 degree. So I'm just in bracket, I'm putting 0 degree. So we know that the cosine value at 0 degree is 1. So it has returned me 1. I wanted to know what is value of pi. So I'm just calling np.pi and I run the cell. That's 3.14. So that's correct. If you wanted to check square root of any value, we can do np.sqrt. Sqrt is a short form for square root. And when you do np square root of 144, we know that it's square root of 144 is 12. Moving to next, if you want to check the log value, so we can do np.log, and we're providing one to check log value for 5.2. When we run the cell, it gives us 1.64, which is correct. By default, it's to the base of 10. And if you want to check the exponential, which is like opposite to log in terms of mathematics, when we do np.exponential of 5.2, that will give you value of 181.27. I hope you are comfortable with this writing, and there are many more expressions with NP which offers different kind of complex mathematical calculation, and you can call all these methods at your disposal if you're dealing with such programs, right? Let's understand Numpy array, and as we discussed in our last video, we dealt with a list, and Numpy array acts similar to the list, but Numpy array can be used in multiple ways. And it is very convenient to use Numpy array. It's very fast in terms of calculation. Hence, we are preferred to use Numpy array, right? So let's understand how do we create Numpy arrays by converting lists, right? So here I'm defining an object called vector. I'm defining an array. And how do we define Numpy array is by calling Numpy. So my method is np.array, and in the bracket, now you know that list is defined with the help of square bracket, just like this. So within square bracket to define the list, within the list square bracket I put 1, 2 and 3. So there are the 3 numbers is there in my list which I wanted to put in Numpy array. And since array is method, I am putting this into a parenthesis. Within parenthesis I put square bracket. That's my list, and then I'm closing my brackets. And that's how I define vector. And then I'm also calling vector to see what values are there in vector. So let me run this cell for you. When I do that, I got array 1, 2, 3. And this is not a simple list, but a Numpy array as we see, right? Now, there are other ways also you can create Numpy arrays. Like one of the way you can create array is through a range method. So it's not a range. We have seen this range in our last video. But np-arrange is acts similarly. So let me show you what is np.arrange. So np is a library Numpy, and we're calling arrange method from it. So arange, and within bracket I'm saying my starting value is 0, ending value is 15, and let me run this. So I'll get similar to the range which we seen in our last video for the list. It will start from 0. So 0 part is included. It will go all the way to 14 while 15 is excluded. So it will give you value from 0 to 14. So that's what we will have it here. When we run this cell, we're calling this object called vector2. So I'm defining vector2 as np.arrange, and it will have values which will be nothing but a list starting from 0 to 14. And I'm going to print this vector2. Then I'm just giving a space here. So that's just print, and in 2 inverted commas, I'm just putting nothing. So it's just giving me a blank space there. In case if you want next line, you can type \n, and that will also be okay. That will give you a new line there. And I'm defining one more vector here, vector3, which is nothing but np-arrange. And here I'm giving 3, 21. So I'm going from 3 up to the value 20 because 21 is excluded at increment of 6. So let me show you here in a previous code. Let me write np.arrange 321, and if I write 6, so it will give increment of 6 till 21. So the first value is 3. After that, it will add 6 increment, that will be the 9. The next value will be 9 plus 6, which is 15. The next value will be 15 plus 6 is equal to 21. But as you know, 21 is excluded. This will not execute. So our list will terminate here. So we have 3 values in this portion, and we are printing that vector3 here as well. Let me run this cell for you, and this will exactly give me what we desired. So our vector2 going from 0 to 14, and vector3 going from 3 to 15 at the increment of 6. Okay, moving on to the next part here, I am defining vector4, and here is our method np.linspace. And what linspace do is it will give me the range between 0 and 10, and it will divide this range into 10 equal parts. And I'm printing that vector 4 for us, and then I'm printing one more blank line for us to keep a space. Next, I'm using the same vector, vector 4, which is having 10 members into it. I'm saying that I don't want one list of 10 members, but give me 5 lists of 2 members each. So what it will do, it will take first 2 members and make one list, then it will start a new list and take the next 2 members, and so on it will do for all the 10 members. So now we have 5 lists of 2 members each. Let me execute this cell for you. As we do that, we know that the first output, which is nothing but our 10 members, which is our vector 4. Now, in the next part, it will take list within list. So you see the 2 square bracket. So it's list within the list. So first list will contain the first and second member of our original list. The next list will contain the second and third member of our original list, and so on. It will do for all 10. So now we have list within list. So we have 5 lists within one broader list of 2 members each. Let's see how we can perform some mathematical operations on array and how we can merge them together if they are of the same size. I repeat again, if they are of the same size. That's very important for here. So I'm defining vector 5, and vector 5 is nothing but np.arange 1 to 6. Now it will have 5 elements. Remember, it will go from 1 to 5 and it will exclude 6. Similarly, I'm defining vector 6, which is nothing but np.arange. It will go from 3 all the way to 8, while 8 is excluded, so it will go from 3 to 7, and it will again have this 5 elements. Now I'm printing vector number 5 here, and also I'm printing vector number 6 here, right? Now I have vector number 5, which is having 5 elements. I have vector number 6, which is having 5 elements again. So when I do vector 5 plus vector 6, it will give me addition of both the vectors with 5 elements, but it will add the respective element in each of the list. It will add up. Similarly, when I do multiplication, vector 5 into vector 6, it will multiply the respective member in that vector and provide me the print output of it. I do 1 divided by vector 5, that is nothing but inverse of vector 5. I can do square root as well and different mathematical functions. So I am writing np.square root for each of the vector 6, give me the square root value and do it in a list format, right? Let me execute this cell for you. Vector 5, as we know, it will go from 1 to 5. Vector 2 is nothing but it will go from 3 to 7. 8 is excluded. When we do summation like vector 5 plus vector 6, which is 3 plus 1, which give me 4 here. 4 plus 2, which is second member, which give me 6. So it's 4, 6, 8, 10, 12 respectively. So that's addition of vectors, because these two vectors, vector 5 and vector 6, are of same size, which is of 5 elements. When I do multiplication, it gives me this output 3, 8, 15, 24, 35. The next one is the inverse value of vector 5. And then the next we have square root of vector 6, which we got it. So this is how you can do the mathematical operations on different Numpy arrays. Now, if you want to find out the unique values in array, so here I'm defining an object called vector 7, which is nothing but np.array. And I'm defining a list here in this Numpy array. I'm saying that I want blue, blue, red, red, purple. So I have total of 5 elements, right? And then I'm printing vector 7. But I want what is the unique values are there in this Numpy array. So that's why I can use this method called np.unique, and in bracket I'm providing find out the unique value from the vector 7. I'm taking printing output of this, and let me run the cell for you. As you can see, now I have my original vector which have blue, blue, red, red, purple, total 5 elements. But if you see their unique values, they are just 3 values, which is blue, purple and red. Let's jump into our next section, understand more about matrices. And this is very important topic as we delve into a lot of machine learning models. You may not define matrices or do a lot of calculation on matrices, but having understanding will help you to easily learn those tasks when it comes, right? So first, let's understand of how do we create matrices by converting lists within the list. So list within the list is nothing but we can put it as a matrices. And how do we do that? Let's understand. So I'm defining an object called mat, which is nothing but like a matrix. So you can define any name here. So I'm just saying that mat is equal to np.array. And within the numpy array, I'm saying that this is list within the list. So if you can see, there are two square brackets here, right? So one broader square bracket is for a list, and I'm giving smaller list within the bigger list. So I'm defining three smaller lists here, 1, 2, 3, and then I'm giving comma to define as a second smaller list, which is 4, 5, 6. And this is my third smaller list, which is 7, 8, 9. And then I'm completing my square bracket for a bigger list. So I'm defining three smaller lists within one bigger list. That's my mat. And print my matrix. So then when I print it, it will print mat. That is nothing but a matrix. And this is how we define the matrix. Matrix is nothing but a list within a list, right? And when you want to see the transposed form of matrix, in our case, our mat is our matrix, right? So I'm just saying mat dot t. So when you do dot t, that means you're telling Python to do the transposed version of matrix, and that will give you the transposed form of matrix. So let me run the cell for you. Once I do that, you'll have this original matrix, which is nothing but 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm seeing the transpose matrix. Let's see a few more methods through which you can create matrix. You can also call method called np.zeros. When you say dot zeros, that means it will create 0, and within bracket you are providing size 5 by 3, and you are saying that print this matrix true. You can also call like np.ones, that will include all the ones. So within the list, it will only have ones, right? And you're saying that this is the size of 3 and 5 here, right? And then you're printing it, matrix 3. And there you are doing matrix 4, we are saying np.I of 5 element. And np.I is nothing but it's kind of a matrix, which is having a 1 on its diagonal and rest all values 0. It's called I matrix, and I'm putting 5. That means it's a 5 by 5 matrix. So just need to give you one input as a number, and I'm putting matrix 4 here, right? Let me run the cell for you. So the first matrix 2, which is np.0, you can see that all the values in the matrix is 0, and it is of size 5 by 3. So you have total of 5 rows and 3 columns, so to say, or just 5 by 3 size of matrix. Then you have a 3 by 5 size of matrix with all the ones. So we have called np.ones. So all the values in the matrix will be 1. So next we have matrix 4, which is nothing but I matrix, and which is nothing but all ones on the diagonal and the zeros of the diagonals. This is what we have. Next we have matrix multiplication. So we have defined our original matrix in mat, so we are printing that matrix. We are also printing our vector. We wanted to multiply this matrix with vector. So I'm using resulting matrix multiplication. I'm storing here as a product object. So I'm defining product is equal to np numpy dot matmul, matmul. So when I do matmul, which is nothing but matrix multiplication, in bracket I'm providing my first matrix, which is mat, and I'm putting vector, which is again a kind of a matrix with 1 row, and I'm printing the product. Let me run this cell for you, and this is what you have. This is the original matrix, a total 9 elements, and then you have your vector 1, 2, 3. When you multiply it, you'll actually get this value, which is 14, 32, 50. Let's quickly see how you can generate samples of random variables. And here you can generate with the help of numpy. You can say np.random.rand, and when you do so, generate this random variable of size 5, 3, and then I'm storing that output into rand_mat. I'm printing that output. Next, I'm doing rand_mat2, and here I'm saying that generate standard normal random variable, and previously I used uniform random variable. So I'm using standard random variable where mean will become 0, and you have a standard deviation of 1. A random variable of size 3, 6, and I'm printing that as well. Let me run the cell for you. Okay, once I do that, I can see the rand matrix uniform random variable, and I can see the size of total 5 rows and 3 columns. So basically the 3 number of entries in each of the list, and I have total such 5 lists. Next, standard normal random variable of 6 elements in each of the lists. So I have 3 such lists with 6 elements in each. And this is how you can create a random variable by using this np.random.rand or np.random.randn. You can perform like different mathematical tasks on matrices as well. np.mean, and you can provide randmat, which is our random matrix that we created, and which will give you mean value of all the elements there in your random matrix. And then we have a random matrix 2, and I'm doing np.standard deviation, which will give me the standard deviation of all the elements put together. Then I can find out minimum and maximum value with the help of np.min and np.max. Let me execute both the cells for you. If you see this first value 0.445, which is nothing but the mean of all the elements which is there. We have total 15 elements, so we have 0.45 as their mean, and then 0.86 as the standard deviation of the next set of 18 values. And then we have minimum and maximum value of mat and mat2 respectively. Now, you can access entries in NumPy vector just the way you did it from your list. So I'm not going to explain in a lot of detail there, but to quickly give you a recap, this is our random underscore vector. I'm defining a random variable of 19 elements, right? And once I execute it, it will give me the random vector as a print, the second element from that list. So let me run the cell. So here is all my 19 variable and give me the second value. So if you remember from our last video, our index in list starts from 0. So this is our 0th element. This is our first element, and this is our second element. Since we want second element, it will fetch minus 0.021, this element for us. Also, if you want a series of entries to be called, you can do like this, 4:9. So it will go all the way from 4 to 8. 9 is excluded. When you do so, it will go from, this is 0, 1, 2, 3, and 4. So it will go from 4, 5, 6, 7, and 8 all the way to minus 0.34, starting from minus 0.18. So minus 0.18 to minus 0.34. It will give me all the values here, right? Okay. Let's move to our next section, and which is again one of the important libraries in Python, and it acts as your very base library which you're going to use for all your machine learning tasks, and which is Pandas, right? Deals largely with data frames. It also deals with lists, but it's more famous and used to deal with data frames. And Pandas is having special data frame, which is called Pandas data frame. Now, if you don't know what is data frame, we'll come to that. So hold on. Before we go there, let's understand how you can import Pandas. So just the way you imported NumPy, you can call import Pandas as PD. So you'll give alias as PD and you'll import Pandas as library. Now, if you don't have Pandas in your system installed, you can again do like this. You will put exclamation mark, you will say pip install Pandas, and you can do this for any package you want to install in Python. So you can run this code in case if you don't find Pandas installed in your computer, you get error while you importing, you can do this, right? And you can run this code. This will install the latest version of Pandas in your system, provided you have internet connectivity, right? Let me comment out this cell for you. Okay. And once you return import Pandas as PD, let me run the cell for you. This will import the Pandas in Jupyter Notebook. Now we can use it for this particular instance. And generally, it's a good practice if you can import all the libraries together at the start. And this will give you kind of good exposure or awareness that what all libraries are using. Let's come back to Pandas data frame. So Pandas data frame is a special feature of Pandas library. And Pandas data frame is nothing but it acts as like an Excel sheet which you have worked so far. I hope so. Data frame is nothing but kind of Excel sheet. It will have a rows, it will have a column, it will have an index, which is index is nothing but rows, and then you have a columns, right? So it acts kind of a table or an Excel spreadsheet, as so to say. But Pandas data frame can be accessed in multiple ways. It's very easy to access, easy to edit, modify, and to manipulate. And hence it is so popular, right? Let's see how we can create a new data frame. So as you know, we can call numpy and we can create a random variable, right? Let's call np.random.randn, and we are saying that give me 5 elements each and give me 5 such lists. And let me execute this. So this is nothing but a numpy array having 5 lists of 5 members each. So far so good. We have not used anything from Panda. We are just calling numpy, and from numpy we have called this list array basically of 5 members each. Now I'm defining this object called df2. df2 is nothing but short form of data frame 2. So I'm saying that df2, which is nothing but pd. Now we are using Panda, so we are saying that pd dot data frame. Now Python is a case sensitive. You need to be very sure what you are writing, else you will continue facing the error. So data frame, D is capital, F is capital. So be sure about writing the same way which I have written here. So pd dot data frame, in the bracket I'm saying use this array and convert this array into a data frame, right? So right now you are seeing array, right? And let's see what happens when we convert this array into data frame. We have put this into pd dot data frame. We are again saying that show us what's there in df, or when you just call a df2, you will get this as a data frame. So now the data which you see in array, which is cumbersome to look at it, it's in now proper like a tabular format, which is easy to read, right? And the entire data is now as in a data frame. Now you don't see the similar number because here you are calling this as separate list, and here again you are saying generate a random variable. So this numbers and this numbers are different. If you want to have numbers same, you can write this as an object. You say that you can call this as a test, and let me generate this for you. And then once you call the test, it will have this number for you, right? So these are the numbers we have now. So you can put test here and run it. So when you run it, you'll get exactly the same number which you have now on your list. So instead of seeing this as a cumbersome numpy array, you can see it in more of a tabular format, which is easy to interpret, which is easy to read, right? And all the numbers which you see on your rows, basically they are index numbers, and the top you are seeing, which is column number. The way you seeing in Excel, it works the same way, right? So this is a Pandas data frame for you. Let's see how we can give labels to rows and columns, right? And Pandas is very important. I wanted to spend a lot of time here. Labels to rows and columns. So how do I give labels to rows and columns? I'm saying that I'm defining this object called df3. I'm saying that pd.dataframe np.random.randn, and I'm saying that 5 by 5, take 5 by 5 random normal variable, give me those 5 lists of 5 members each. So I'll generate that data frame, and within data frame I'm saying that give the index a name like row 1, row 2, row 3, row 4, row 5, right? And also give column name like column 1, column 2, column 3, column 4, column 5, right? And this I'll store in data frame 3. Let me execute this for you, right? So now we have numbers, random numbers generated for us. It's a 5 by 5, but instead of having just 1, 2, 3, 4 as a column, I have explicitly given names of the columns by this way. So I'm saying that columns are nothing but I'm giving a list of columns that I want my first column to be col 1, col underscore 2, col underscore 3, so on. And for each of my index, I'm giving a list in square brackets saying that the first row has to be called as row underscore 1, row underscore 2, row underscore 3, and so on. Then this is how I define my data frame 3. So now my data frame 3 has a name of index and name of columns, right? Now, how can you access the values from Pandas data frame, right? Let's first see how we can access value of different columns, right? So this is our df3 as we know, right? And if you wanted to access a particular column from this data frame, what we can do is we know that this is our data frame df3. So we'll call it as df3. And the same way you call the value from your list, the same way in square bracket, I'm saying that give me col 1. Now, since col 1 is a name of the column, I'm putting into an inverted comma. Now it can be single inverted comma or double inverted comma, but make sure you use uniform for that method. In between that, you are putting name of column. So here I wanted to call column 1 only. I just wanted to see what's the value there in column 1 across all my rows. In call underscore 1 in square bracket for data frame 3. Let me execute this for you. And this will give me value of column 1 across all rows. So it's 0.72 minus 0.77 minus 0.26 and so on. This is what I'm getting it here, right? So that's output I have. And this is just column 1 which I'm seeing it. Now, what if you want to see 2 columns? So if you want to see 2 columns, you can still call in a square bracket. But remember, now you are providing more than 1 column. So you cannot just simply say, because you now want a list of columns to be seen. And how do you define list is with the help of square brackets. So you will define, and since it's a name of column, I'm putting into inverted comma saying that call underscore 1 and comma call underscore 2. So it's a list of column that I wanted to see, hence it is in square bracket. And again, you are calling a column, so you are putting that into list. So it's 2 square bracket in here. Be careful about this, else you'll keep on getting the error. So it's very important to you to follow this syntax. When I run this cell, it will give me output of column 1 and column 2 only. It has not given me column 3, 4, and 5, and give me for all the rows, right? Let's see how you can access the rows from a data frame. So this is my data frame 3, df3 object. Let me run this. And this is how our data frame look like. And from this data frame, I wanted to access my row number 2. Like I wanted to see what's there in just row number 2, irrespective of column. So I wanted to see what all values are there in row number 2. And I can use this method called dot lock method. Dot lock is nothing but dot location. So I'm saying that take df3 data frame and dot lock. So that means dot location. I'm saying that this is the location I wanted to see. When I run this cell, I'll give value for this row number 2 for all the columns. So it will give you column wise what is the value which I have in row number 2. So it's 0.77 for column number 1, which I have here, minus 1.97 for column number 2, which I have here, and so on for all the 5 columns, right? Now, you can simply access with I location as well. So I is basically when you want to give it by number rather than by name. So you can simply say df3.ilock in bracket 2. And when you execute it, it will give you value for your 3rd row, right? Now, why 3rd here? Because you are giving index location. Remember, it's ilock, index location. And our index in Python starts from 0. So in essence, you are getting all this value for your 3rd row, right? That's what you are having it here when you do ilock. When you do lock, you can give a name of your row and you'll get the values. When you do ilock, it will give you index location wise, right? Now, this is for rows and column. What if you want to access a specific entry just like this? Only the one value or a specific set of values from this particular table. How do you do that? So let's call our df3 again. To see it, this is how our df3 look like, right? And I wanted to see what's there in my row 1 and row 2 and between column 1 and column 2. So df.lock, I'm calling location method here, and within square bracket, I'm providing 2 lists. I'm saying that provide me row 1 and row 2. Also, comma, provide me column 1 and column 2. And once I execute this, it will give me value of row 1 and row 2 for column 1 and column. And this is how you can use dot location method to access a specific entry in your from your pandas data frame, right? Let's see how you can use logical operators for indexing data frame, just like Numpy Arrays. This is my df3, right? And I wanted to see only the values which is greater than 0. So I wanted to compare it. So whenever I write df3 greater than 0, what it will do, it will go each individual column and it will check for each of the value whether it's greater than 0 or not. If it's greater than 0, it will give you true. If it's less than 0 or less than equal to 0, it will give you false, right? So let me run this. So for each of the value, it will iterate and it will give me whether this value is greater than 0 or not, right? So this is more kind of a Boolean comparison because here we have compared with the help of mathematical operator or conditional operator, right? But if I wanted to see the matrix which is having just this value, I wanted to call only that. I can do that putting this condition into the square bracket, take the data frame 3 and in the square bracket, use this condition. So wherever the entry is matching to this condition, like wherever it's greater than 0, provide me only those values. Now this is a very, very powerful method which you often use it. So when you run this cell, you will get all the values which is just greater than 0 and the rest of the value will appear as a nan. Nan is nothing but it's a short form of not a number. It's basically there is no value in there which satisfy this criteria. So that's why you're getting nan here, right? So nan is nothing but not a number. So only the values which satisfying this condition, you are getting that from your data. Let's see how you can add columns to the data frame. Now remember how our data frame 3 currently looks like. Let me call data frame 3 and let me run this. So this is what our data frame. Now if I wanted to add column number 6 here, so you can simply add a column saying that df3 in square bracket, use the name of the column that you wanted to define. So I wanted to define my new column by call underscore 6. That's why I put it in inverted comma in square bracket. What this column value it will take. So I'm giving is equal to and I'm giving all the 5 values because I know there are 5 rows in there. So I need to provide 5 values, right? So I'm giving 6, 3, 7, 8 and 5 as a value and then I'm putting df3 again. When I do so, I now have column number 6 with all the 5 values are here, right? Now, what if I want to drop any column from the data frame? It's very easy. You can do it multiple ways. Let's see one of the way how we can do it. So I'm calling data frame 3. I'm using this method called dot drop. Dot drop is meaning you wanted to drop something, whether it's row or column. You can use, so when you use dot drop, you are saying that you wanted to drop this particular object and you are saying that inverted comma call underscore 1. Now Python don't know what is call underscore 1, whether it's column or it's row. So you need to say what you wanted to drop when they find call underscore 1, whether you wanted to drop row or column. So that's why you define axis. When you say axis is equal to 1, 1 is nothing but your column. And 0, that means it's your row. So either you have a 0 or 1 as an axis. So when you say axis is equal to 1, that's when the drop method will understood that it's a column. So it will drop the column 1. And when you use in place is equal to true, that means you are storing this changes in the data frame 3 without assigning. So when you do in place is equal to true, that means it will execute these changes in your existing data frame. Let me run this cell. And so when I call df3, it will give me all the columns except for call 1. So call 1 has now been dropped from our data frame, right? Let's now see the other way of doing the things. And here I'm not using in place is equal to true. So I'm defining a new data frame 4, df4. I'm saying df4 is equal to df3 dot drop column number 2. And I'm saying that column number 2, I don't want column number 2. I'm giving x is equal to 1. So that means it will drop the column number 2 as well from data frame 4. And let me execute this. And this is how our data frame 4 look like, right? It will have column 3, column 4, column 5, and column 6. It will not have column 1 and column 2, right? Now, we can remove rows from data frame. As I said, you can use similar dot drop method. And I wanted to drop row number 2. That's why I give access input as 0. So I'm saying in data frame 5, I don't want row number 2. When I execute this, I don't have row number 2 here. So I have row number 1, 3, 4, and 5, but not row number 2, right? And as you can see, your index has been changed, right? Because you are deleting rows from your original data frame. And if you want to reset index, you can do resetting of your data frame's index with the help of dot reset underscore index method. And you do df5 dot reset index underscore, and when you execute this, it will give you this output, right? It will reset your index. But nothing has changed. Why? It's because you have not executed these changes in your data frame. You just wanted to execute this, but you're not really saved these changes in your original data frame. Had I done something like this, df5 is equal to df5 dot reset index, then I would have seen the changes get executed, right? So either you can do that the way I've shown you, or you can just in the bracket reset index, you can write in place is equal to true. And true, you see, is T is capital. So that a Boolean value which you're giving, you're saying that in place is equal to true. That means retain those changes in data frame number 5, right? And when you execute this cell, it will give you the new index now, which is 0, 1, 2, and 3. This is your new index. However, your original index, which you have, row 1, row 3, row 4, and row 5, which will be set as a new column called index. Now, this is not an index per se, but it's a column called index. So your new index is 0, 1, 2, and 3, and over your previous index will be saved as an index, right? And you can drop that index as well as a column if you want to, right? Now, if you want to assign a new index to this column, and let's do that. So before that, let's add this new column in our data frame 5. So I'm adding a new column called df5, and I'm defining the name of new column as new, and I'm putting this 4 different values in there: alpha, beta, Charlie, and delta. And let me execute this df5 here. Once I run the cell, I have alpha, beta, Charlie, and delta as a new column included up in my df5. I wanted to set this, my new column, as my index. So what I'll do, I'll say that df.5, and I'm using this method called dot set underscore index. In bracket, I'm saying that use this column called new, and I'm saying that in place is equal to true so that you retain those changes in df5. Let me execute this cell for you. Once I do that, my new column will be set as my index now, right? And I don't have new as a column, it's my index here. Right? This is how you can set any column as your index if you wish to do so. Okay, now you've learned all this method. If you want to export this data frame into maybe an Excel file or CSV file, you can do that from here, right? df5, and I want to export this data frame to a CSV format to give it to somebody else in a mail or maybe some other way. So I'm saying that df.5, and I'm using this method called dot to underscore CSV, to CSV, store this file, and then I'm giving the file name, like what would be my file name. I'm saying that df5.csv, that's my file name. And I'm saying index is equal to true. That means keep my original index there in the file. And once I do so, and once I execute the cell, this file will get stored in your default directory in which your existing Python file, this file is there. Now this file is there in my folder. So the file which I'm exporting, CSV file, will go and sit there. So let me run the cell for you and take you to the folder in which I have this file. So as you can see, this df5 file now just been recently exported. So let me open this df5, and once I do so, it will open. Along with index, we get our data frame stored in a CSV format file. Let's go back to our file, and you can read CSV file directly. Let me close the CSV file here, and you can read CSV file or Excel file directly. And I'm calling new data, new underscore df5 will be my object. I'm saying that pd.read underscore CSV, and I'm saying read this df5 CSV file. I'm giving index underscore column as 0. Take 0th column, index column, and show me how the new df file look like. So it will read from this CSV file which is stored and stored it in a new data frame. So this is what we have right now with us. Now you can export your data frame to Excel file as well, and this is how you can do it. df5.to underscore Excel, df5.xlsx, comma, index is equal to false, sheet name is equal to first sheet. Once you do that, and I'm again reading that Excel file again to see how newer df file look like, but let me run the cell for you. So once it got executed, first it has gone and exported this df file into Excel format. So when you open it, this is how our df file look like, right? In Excel file, we have again go and read the same file here, and this is how it does look like, right? And here index column is equal to 1. So it has taken the first index column, and this was the first column, right? So this column 2 is now become our index column, as you see. So that's all for today. And you have learned a lot about Numpy and Pandas, very, very important library. I request and I recommend you to practice. You can pause the video, do practice simultaneously along with me, or watch video multiple times. If you like the content which I put for Python, please hit a like button. Please subscribe my channel. Give me comment like where I can improve, or what's good part you liked about the video, what's not so good part. Please like, share and subscribe my channel. Thanks for watching. Bye-bye.